Our daily lives are powered by energy. But where does this energy come from? Let's take a look. The energy we use comes from many different sources, and these are broken down into two types: renewable and non-renewable energy. Most non-renewable energy, such as coal, oil and gas, comes from the remains of ancient plants and animals that lived millions of years ago. As the years went by, these remains were buried under mud and sand, and the pressure and heat from the earth turned them into hydrocarbons. Non-renewables have been important in powering our daily lives since the 1700s, but unfortunately they produce a lot of pollution, which has had a huge impact on the climate. There's also a limited supply of these fuels, and once they're gone forever. This is why we need other energy sources. Renewable energy, as the name suggests, won't run out. We can produce energy through harnessing wind, solar, hydro and geothermal power and use it again and again. Each natural source will either power a generator or create a chemical and physical reaction to give us energy, but some are more reliable than others. That's why we need an energy mix. Each country around the world has its own energy mix, and many are trying to reach net zero. This means cutting carbon emissions to a small amount that can be absorbed by the environment, so we're not adding any more into the atmosphere. Two countries who are committed to net zero are Norway and Scotland. So let's see where their primary source of energy comes from.
Welcome to Norway, a country renowned for its beautiful landscapes. Today we are in Jøssingfjord, Rogaland, to explore how water can be turned into electricity.
To understand how water can generate power, let us start with a simple experiment. In this experiment, I've made my own turbine out of a bottle and straws. So let us now see what happens when I pour water into the bottle. We can now see how the water pressure makes the turbine spin. So this is just a basic example that shows us how running water can run a generator. And now, Advar, why don't you show us what it looks like in a real hydropower plant?
Sure thing. We're now further down in Jøssingfjord in the Nedre Helleren power station. Historically, this made electricity for local community in the industry and the homes. You can now see in front of us the two generators and turbines made back in 1935. Why don't we have a closer look at the turbine itself? This is a Francis turbine, the cornerstone of hydropower for the last 100 years. The water actually flows in from the underside. You can barely see the pipe coming up from the floor here, and the water is guided around a runner and is pushed at different levels in towards the turbine, and then you can see the water pipe disappearing into the runner that's inside here. And then the water then goes through the runner, creates the rotation, and the water is pushed further down this pipe. Connected to the turbine is the generator, which makes the kinetic energy into electrical energy with a magnet and a copper spool. And even though this is really old equipment, the principle remains the same and is used in modern plants today. As it was quite hard to see inside the turbine we saw previously at Nedre Helleren power station, we've now moved a few kilometers to a more modern and larger turbine at Åna Sira kraftverk. This turbine actually have a weight of 25 tons, and when it was running, it spun at 150 turns per minute. Imagine a casing around us here, and that will press the water towards the runner blade. The water flow will hit these giant vanes and create a spin on the runner blade that will run the generator, and then the water will flow through the bottom and exit. Hydropower is a cornerstone of Norway's renewable energy strategy, providing clean, reliable and sustainable electricity. By harnessing the natural power of water, Norway is paving the way towards a greener future.
Thanks, guys. Let's see what Scotland has to offer.
Welcome to Scotland, a small country that packs a big punch. From our sweeping landscapes to our rugged coastlines, there's one thing you'll always encounter: wind. Wind is Scotland's greatest source of renewable energy, and it continues to be developed throughout the country. Behind me, you can see Eneco's Tullow and Twinshields wind farm in Aberdeenshire. Most wind energy is produced by onshore wind farms, but it's expected that offshore wind will exceed this capacity in years to come. But why is Scotland good for wind energy?
With the country having the Atlantic Ocean to the west and the North Sea to the east, we're exposed to strong westerly winds throughout the year. So how does wind turn into electricity? Let's have a look.
Like we saw with water, kinetic energy turns a generator and produces electricity. The same is done with wind. But how can we make sure we get the most turns out of each gust of wind? There are many variables engineers need to think about when it comes to the blades on a wind turbine, such as how many there are, the shape of them, and the angle that they're pitched at.
Here we have some paper blades attached to a cork. When I turn on this fan, we can see we don't have a lot of movement. If I change the angle or pitch of the blades, I can harness more kinetic energy. The same thing happens with real wind turbines. There are control systems in place that adjust the angles of the blades as well as the yaw system, which controls the alignment of the nacelle, the main body of the turbine sitting on top of the tower. With the blades at the optimum pitch, the moving air blows towards them, causing the rotor to spin around and turn the central drive shaft. Inside the nacelle, the gearbox converts the low-speed rotation of the drive shaft into high-speed rotation, fast enough to drive the generator efficiently. The generator, immediately behind the gearbox, takes kinetic energy from the spinning drive shaft and spins magnets inside a loop of wire, which creates an electrical current. By utilising the wind, Scotland can continue to power the way to net zero.
To reach net zero, we need to continue using renewable energy and cut carbon emissions. By using the resources around us, we can continue to power our daily lives. What would you use to keep the lights on?